Welcome to this explainer. You know that feeling when you're staring at the massive wall of tiny bottles in the pharmacy eye drop aisle? It's completely overwhelming. Well, today we are going to demystify all of that. We're looking at ocular pharmacology through a highly practical clinical lens. We're not just looking at what the box says, we're going to see exactly how these drops interact with the actual biology of your eye. To set our clinical ethos right from the start, we're taking some major inspiration from Dr. Dirk J. Buijsen. He literally built a DIY practice eye out of cardboard and tape just to practice indirect ophthalmoscopy. Why? Because to truly treat an eye, you have to understand it as a dynamic mechanical system, right? You can't just treat a random list of symptoms. And that is exactly the hands-on philosophy we're bringing to the pharmacology today. Okay, here is the roadmap for our explainer. We'll start with a hands-on clinical approach, dive right into the vicious circle of dryness, and look at mimicking natural tears. From there, we'll cover vasoconstrictors, a palliative Band-Aid, then antihistamines, blocking the itch, and finally, choosing the right drop. Section 1, a hands-on clinical approach. Systems, not just symptoms. Section 2, the vicious circle of dryness, the mechanics of dry eye disease. The biological reality of dry eye disease is quite literally a vicious circle. It starts when tear hyperosmolarity, which basically means your tears become way too concentrated, and epithelial injury starts stimulating your corneal nerve endings. This causes intense discomfort and kicks off a whole cascade of inflammatory events. And here's the worst part. That inflammation causes more cell damage, which further disrupts the tear film, creating this self-amplifying destructive loop. Once the circle starts running, it just feeds itself. There are really two main entry points into that vicious circle. First, we have aqueous deficient dry eye. This is where the eye simply lacks tear volume, usually because of some dysfunction in the lacrimal gland. Second, though, we have evaporative dry eye. With this one, the lacrimal function is totally normal, but there's a deficiency in the protective meibomian lipids. Without that essential oil layer, normal tears just evaporate into the air way too quickly. But regardless of the entry point, both pathways drop you right into that exact same inflammatory loop. Section 3, mimicking natural tears, healing the ocular surface. So knowing how that vicious cycle works, how do we actually intervene and heal the eye? Well, modern artificial tears use some incredibly high-tech polymer formulations to basically rebuild your tear film. They act like tiny molecular sponges and shields. Take polyethylene glycol, or PEG. It acts as a soothing demulcent that forms a protective layer. Then there's propylene glycol, which is a humectant that actually holds water. You also have cellulose derivatives, like carboxymethylcellulose, or CMC, which physically binds to your corneal epithelial cells, along with viscosity promoters like HPMC and hydroxypropyl guar. Working together, these polymers perfectly reproduce the characteristics of natural tears, lower that tear film osmolality, and actually short-circuit the dry eye vicious circle. And you're going to see these exact restorative polymers on the pharmacy shelf in a bunch of different forms. They range from standard drops meant for daytime use to much thicker gel drops and ointments designed specifically for nighttime. The rule of thumb here is simple. The thicker the product, the longer it stays on the eye. That prolonged contact is absolutely essential to give the ocular surface the time it needs to truly heal overnight. Section 4, vasoconstrictors, a palliative Band-Aid, the truth about the red eye fix. Now we're shifting away from those restorative lubricants to the classic quick fix for red eyes, ocular decongestants, also known as vasoconstrictors. The crucial thing to understand here is the chemical chain reaction. When you put in a synthetic adrenergic agonist, stuff like phenylephrine, avzoline, or tetrahydrozoline, these drugs directly stimulate alpha receptors in your eye. This sympathetic nervous system stimulation literally forces your conjunctival blood vessels to constrict and shrink down, which of course dramatically reduces the visible redness. But keeping Dr. Buijsen's clinical reality in mind, treating a symptom is definitely not the same as treating the system. Like the pharmacology guides explicitly tell us, this is merely a palliative Band-Aid. It is not a cure. These drops have absolutely zero effect on whatever underlying issue is causing the redness to begin with. And actually, it gets worse. Using these vasoconstrictors frequently can cause a severe rebound redness when the drops wear off. Plus, they provide so little actual lubrication that they can make a dry eye significantly drier. Section 5, antihistamines, blocking the itch, the ocular allergy battleground. Our final category tackles a fiercely uncomfortable problem, the intensely itchy red eye caused by allergic reactions and massive mast cell degranulation.
When your eye encounters an allergen, its mast cells dump out histamine. This histamine then actively seeks out two specific physiological locks in the eye. First, it targets H1 receptors located right on the nerve endings. When those are stimulated, boom, intense itching and capillary permeability. Second, the histamine hits H2 receptors on the blood vessels themselves. That causes the vessels to dilate, which leads to massive hyperemia or redness.
So what's the fix? Well, antihistamines act as specific blocker keys. They reversibly bind directly to those H1 and H2 receptors. By sitting inside the receptor, they essentially jam the lock so the free-floating histamine can't get in. By successfully blocking the H1 receptors, you stop those nerve endings from firing off that maddening itch, and by blocking the H2 receptors, you completely prevent the capillary dilation. Problem solved at the molecular level.
Section 6. Choosing the right drop. Applying the clinical mindset.
Let's bring all this pharmacology together into something you can actually use. Proper clinical care, exactly the kind Dr. Bouillon advocates for, means we're not just guessing based on the color of a box in the aisle. We are matching the exact mechanism of action to what your eye's biological system actually needs. If your system is stuck in that vicious circle of dry eye, you need to use restorative polymers like CMC and PEG to rebuild the tear film. If your eye's freaking out over an allergen, you deploy antihistamines to specifically block those H1 and H2 receptors. And you only ever use vasoconstrictors like tetrahydroxyline as very temporary palliative band-aids, knowing full well they aren't actually curing anything. So the very next time you find yourself staring blankly at that overwhelming pharmacy wall, what's it going to be? Will you just blindly grab something to simply get the red out? Or will you think like a clinician, analyze the system, and find the exact molecular key your eye actually needs to heal? Thanks for joining me on this explainer. I hope it helps you see things a little more clearly.